what we realize that this equation over here, right? The highest polynomial is negative, so it's going to have a set phase sort of profile. Okay, so now we know that over here, right, is equal to minus 25 times 10 to the power 3 z squared. So that is from point A to point B, right? So the next thing that we do is we're going to look at point B. So point B is where Z, sorry, this is not X, Z is equal to 0.8. Okay. So as you can see, when Z is equal to 0.8, what we're going to get down here, it's not an equation, but it's going to be a what? A constant value. Okay, so it's not going to be an equation, it's going to be a constant value. So now, again, I draw the free body diagram. Right? So now this is point A, and this is point B. And at point B, we know the distance from here to here is equal to what? 0.8. So this value over here is 50 times 10 to the power 3 multiplied by what? 0.8. Okay, so 50 times 0.8 is equal to 40,000. And the distance from here to here, right, we have a distance from here to here is equal to 0.4. And then we assume positive shear and positive bending moment assumption. Okay, so we're going to take our moment from there. Okay, but at point B, we know that there's a load going up, right? This load that's going up, we calculated is 120 times 10 to the power 3. Okay, so it's equal to 120 times 10 to the power 3. Okay, so we are going to do again static analysis. Summation of forces in the y direction is equal to 0. So you have minus 40 times 10 to the power 3 plus by 120 times 10 to the power 3. And this will be equal to 80 times 10. Sorry, I missed another equation. So minus V at point B is equal to 0. So V at point B is equal to 80 times 10 to the power 3 Newton. Okay. Again, we do summation of moment about in the x direction, and the distance is 0.8. So this is equal to 40 is equal to 0. So this will be equal to going anti-clockwise 40 times 10 to the power 3 multiplied by 0.4, right? The 120 is not going to cause any moment, right? It's because it is there's no perpendicular distance at point B, right? Of due to the 120, and then you plus by m at point B is equal to 0. So m at point B will be equal to 40 power 3 times 1.4 is equal to minus 16 times 10 to the power 3 Newton meter. Okay, so we know that this is minus 25 times 10 to the power 3. No, not 25, 80 times 10 to the power 3. And the other one is minus 16 times 10 to the power 3. Okay. So that is our point B. Okay, so I'm going to do from point B to point C. Good news is we know that at point D, right, is also equal to 0. So we have two more equations to go. Okay, if you guys are wondering. Okay, and then we have one more constant to find. So now we're going to do from point B to point C. Right, so I will string down the diagram. So from point B to point C, we know our limits is 0.8 Z. So 0.8 plus 2.4 is 3.2. Okay. So from here, again, we do the same thing. So we know that this is our point A. We know at point B, and at point B, you have a force going up. And at point B is going up by what, 120. So 120 times 10 to the power 3. You have a evenly distributed load, which is 50 times 10 to the power 3 Z. Okay. So this distance from here to here, this distance, okay, is equal to Z. We also know the distance from here to here, right? This distance is equal to Z minus by 0.8. So it's important to get all your distance right. And we also know the distance from here to here is equal to Z divided by 2. Okay. Again, we do positive shear and positive moment assumption. So this is V as a function of X. This is Z as a function of Z, right? So again, we do static analysis. So going up is positive. So 120 times 10 to the power 3 minus by 50 times 10 to the power 3 Z, and then minus Vz, right? So we know that V as a function of Z is equal to minus 50 times 10 to the power 3 Z, right? Minus 50, so Vz equal to minus and plus by 120 times 10 to the power 3. Okay. So that is our shear force equation, right? So minus 50 times 10 to the power 3. So we come back here. Minus 50 times 10 to the power 3 Z plus by 120 times 10 to the power 3. Okay. And then we do our moments. I mentioned about moment in the x direction anywhere at point Z is equal to 0. So where the dot is where we take our moment, right? So we know that the 120 is going clockwise. So minus 120 times 10 to the power 3. And there is Z minus 0.8. Then the other one is plus. I'll bring this over here so I don't need to move this so often. And then we plus 50 times 10 to the power 3 Z multiplied by Z divided by 2. And then any more. Okay, 50 times 10 to the power 3 z, yep, z over 2 is positive, plus m as a function of z is equal to 0. Okay, so when we expand this term, we get minus 120 times 10 to the power 3 z plus by 120 power 3 times 0.8, 96 times 10 to the power 3 plus by 25 times 10 to the power 3 z squared, and then plus by m as a function of z is equal to 0. Right. So now what we have is m as a function of z is equal to what? Is equal to minus 25 times 10 to the power 3 z squared, and then plus by 120 times 10 to the power 3 z. Right. I better get all this right. Minus, plus, and then minus 96 times 10 to the power 3. Okay. So that is your equation from point B to point C. Okay. So I will write this down. Minus 25 times 10 to the power 3. Then plus by 120. Right. Plus 120. Let me shift this a bit. And then minus 96. Okay. Now I'm going to do point C, and I'm going to do from right to left analysis. Okay, we have to see what is going on point C. Okay, so at point C, I'm going to do something different. Okay, at point C, where x is equal to 3.2 meters. Right, I'm going to do something different. I'll show you what. The geometric datum will still be on the left hand side. Okay, so this is our 3.2. But I'm going to analyze a vertical. This will have a vertical force of 40 times 10 to the power 3. And we know this distance, right, is equal to 0.8. And this is exactly at point C, right? So now when we analyze from right to left, right, the shear force positive is going up. So V at point C, and the moment now is going in the opposite direction, is going in a clockwise direction. Okay, so I'm going to write something out. Okay, so for analysis from right to left, positive shear and positive bending moment. Now it's going up, so V is going up, and moment is going in a clockwise direction. Okay, so this is the positive shear and positive bending moment assumption. Okay, so when this is the case, right, plus dimension